So my name is Miss Brubaker and I teach fifth grade at Sarah Moore Green. I am so excited to join you today as we continue to talk about classifying 2D figures. So this is our standard. We are classifying two-dimensional figures into a hierarchy based on properties, and we're understanding the attributes belonging to a category of two-dimensional figures also belong to all subcategories of that category. Okay, so that's a lot of math jargon in there, but they give us an example, and it says that all rectangles have 4 right angles and squares are rectangles, so all squares also have 4 right angles. Okay, so we're going to kind of break this down a little bit just so we make sure we understand, we have a deep understanding of what's happening here. Okay, so what it's asking us to do is, first of all, we're going to classify. We see that verb, okay? And that word classify, you guys have been doing that for, since you were in kindergarten, classifying things by color, by shape, by size. When we look at things, we are classifying it, okay? Two-dimensional figures, those are those flat plane figures. So if you saw way back when we did a video on, using that coordinate plane, that's what it's talking about, two-dimensional, okay, those flat figures. And hierarchy, so that's that vocabulary word. We're going to use that. When I think of hierarchy, I actually think more social studies. I think about going from kings and queens to maybe princes and princesses to knights and all of those sorts of things. That kind of goes in my brain, but we're going to talk about some real life examples where we see a hierarchy based on properties. So properties are just those attributes. Those kind of mean, we're talking about the same thing here. Properties and attributes as characteristics. If you think about in reading or in language arts, if you're thinking about a story and you are talking about characteristics of a character or attributes of that character, then that's something that would describe them, okay? So here are the math practices, and really this is how we're going to do this math. This is how we know that, hey, I've got this, I know what I'm doing. The math practices are super important, especially if if you're in my math class, we use them all the time. I can promise your teacher uses them too. So we are reasoning abstractly and quantitatively. That's that whole, can we take numbers out of a word problem? Can we do something with them, and can we apply it back? Okay, we are constructing viable arguments and critiquing the reasoning of others. This is super important. So we're going to listen to somebody else's thought process, and then we're going to say, yeah, I respectfully agree with that because of this, or I respectfully disagree because of this. Okay, you're going to model with math. So anytime you are drawing, you are looking at shapes, you are modeling with math. Friends, if we're talking about shapes, we should be modeling. We should be able to construct arguments because we can draw what we're talking about. Even if you're not the best artist, that's me, okay? Use appropriate tools strategically. So our appropriate tools here are those shapes. Are we able to, take a quadrilateral and really show that it's a polygon, those sorts of things. Attend to precision, okay? When we attend to precision, that means we are exact. And it's very important in all of math, really, but in shapes to be exact, we need to know that, hey, a polygon is a closed figure. It has line segments, 3 or more line segments. All of those things make it exact. And then we are looking for and making use of structure. Friends, that's just, can you find a pattern? You guys have been finding patterns since, kindergarten. You have been creating those patterns. So math practice number 7, to me, I think is kind of the easiest. We should see a pattern, because if we don't, then how are we going to know we're right? All right, so let's get into some of those definitions that we were talking about. If I look at hierarchy, the actual definition says a ranking of categories based on properties, okay? So you're kind of ranking things. You're kind of, when I think about ranking things, I think about, hey, this is the best, this is the best to worst. But here we're actually thinking this is the most general, which means it covers more things, to the most specific, okay? So we do that in a variety of ways. We do that through a Venn diagram, which I know, again, in your ELA and your reading classes, in science and social studies, you guys have used Venn diagrams. This is nothing new. We use a flow chart, or we could use a tree diagram. Now, I don't have an example of a tree diagram on here, but it's kind of fun because to me, a tree diagram kind of meshes the Venn diagram and the flow chart together, okay? So if we look at this Venn diagram that they have for us, this is the actual example from the book that they give us. It says a Venn diagram can show those categories and subcategories. So I want to take a moment here and talk about that prefix sub. Sub means under, okay? So it's a category that is under another category, which makes sense because I think sub, like submarine. Submarine is under the water, so under. In this particular diagram, Venn diagram, it looks like we are looking at quadrilaterals, and they're saying that's the most general, okay? So any of the things that we see inside of that should be a quadrilateral. So let's make sure we understand that, okay? The next one that we see is parallelogram. Well, I know a parallelogram has 4 sides, and a quadrilateral is a polygon with 4 sides. So, yep, a parallelogram, if it has 4 sides and it's a polygon, then it's a quadrilateral, okay? A rectangle, well, I know a rectangle has 2 sets of parallel sides. So if it has 2 sets of parallel sides, then it is a parallelogram. It means that a rectangle, if it has 2 sets of parallel sides, would have 4 sides. Well, that makes it a quadrilateral, okay? And then underneath that, we see squares. Well, a square has 2 sets of parallel sides. It also has 4 right angles, which makes it a rectangle. We already talked about a rectangle being a parallelogram and a parallelogram being a quadrilateral. So one of the things here that I really want to make sure we understand is that as these circles get smaller, that means you're getting more and more specific, okay? The ones like the quadrilateral, how it's the very first one, that's the most general, and that's important that you understand that that's how we're kind of reading. We're going from the outside in instead of from the inside out, okay? So really thinking through, if I were thinking about this, quadrilateral is very general, square is very specific, okay? You could also do this using that flow chart. So if you look down there, that flow chart kind of says the same thing. We went from quadrilaterals first to parallelograms to rectangles to squares. And I had a kind of a thinking question that I want you to think about as we're going through this. How are the flow chart and the Venn diagram alike? So just stop and take a moment. How are they alike? How are they different? So I'm sure you've come up with lots and lots of thoughts. If we're thinking about these the same, it's kind of the same flow of words, and it should be the same flow of words because they're describing the same thing. So in a flow chart, we're kind of flowing from most general down to the most specific. I think of a flow chart kind of like we're going from a big waterfall all the way down to that little stream, okay? And if they're different, you know, it's just the presentation. It's just how it looks is a little bit different. For you, you might be more comfortable with a Venn diagram because you've been using it so long. For somebody else, they may be more comfortable with that flow chart, and that's okay. It doesn't matter which one you use unless they specifically ask you for one. All right, so now we're going to get into a polygon. So you all have been working with polygons for a really long time. I know that for most of you, you guys actually started looking at polygons in like 1st grade or so, and we're going to take that, and now we're going to be able to classify these polygons, okay? So a polygon is just a closed 2-dimensional shape. Remember that 2-dimensional is flat. It's able to go onto that coordinate grid. And it's made with 3 or more line segments. So that makes sense because the smallest possible polygon is going to be some sort of triangle. And the reason for that is because if you only have 2 lines, there's no way to really connect both of those lines the same way, okay? So here are some examples of polygons. We have quadrilaterals, squares, hexagon, parallelogram, trapezoid, and triangle. Now I know you may be thinking, hey, Ms. Brubaker, several of those on there are also quadrilaterals. And if you're thinking that, give me an air high five. Yep, because you're right. So quadrilateral is just a polygon with 4 line segments. That's all, okay? It has to have 4. And so we see here quadrilateral has 4. Obviously square has 4, so it is also a quadrilateral. Parallelogram has 4, also quadrilateral. Trapezoid has 4, also quadrilateral. And as we get into this, it's going to make more sense. Friends, you're going to see, you remember back from 4th grade, there are lots of different types of triangles. There's scalene, there's equilateral, there's obtuse, there's right. All of those types of triangles are also just triangles, okay? Triangles is the more broad category. But just thinking through that, a hexagon, of course, has 6 sides. Pentagon has 5 sides. All of those polygons that you've talked about, all of those shapes that are in fact closed and have 3 or more line segments, those are the things that we're looking at right now as polygons. Okay, an attribute is any characteristic of an object or shape, like the number of sides, the color, the angle measurement. It can be any of those things. So down here, and you have this in your packet, are some of the specific things that we've kind of looked at. So if we're grouping polygons into categories based on their attributes, basically we're looking at them and we're going to put them into categories based on something, okay? So if we're saying that it's scalene, remember from 4th grade, scalene triangles, they don't have any sides that are equal. Every side is different, okay? An isosceles triangle, it's going to have at least 2 sides that are equal, and it may or may not have one that is different. Equilateral, every side is going to be equal no matter what. Looking at each of those, you're going to notice, remembering back again from 4th grade, if I see those red slashes is what they have here, that means that, hey, this is equal to this one. If I see the little red squares inside of a shape, that means, hey, this is a right angle. So thinking through those things, this is just a nice review of all of the things that you learned, and you already know all this stuff. Okay, so when I do a problem in my classroom, we use guided questions, and these guided questions are not perfect. They might be something where you're like, hey, this is really helpful, and for some of you, you're like, I already know how to do this, I don't need those. I just have these here as a guide, and I'm going to think through them because that's the expectation in my classroom, is that my students are using those guided questions to kind of think through all of the problems that we have, okay? So I noticed this problem right here, and it says, look at the tree diagram below, write a statement about the relationship between acute triangles and equilateral triangles. Okay, so this is that tree diagram that I was talking about that I didn't have an example of. We've talked about flowchart and we talked about a Venn diagram. So looking at this tree diagram, my very first guided question says, what attributes do I notice about the shapes? And the reasoning for that is I'm going to reason abstractly and quantitatively, which if you'll remember is at math practice number 2, okay? So I need to take out some pieces from this diagram and I need to think about them, and then I need to be able to apply them back, okay? That's all that means. So if I'm noticing these shapes, I notice that triangles is kind of bold, it's at the top, and what I know about triangles is that they are polygons with 3 sides. Just polygons with 3 sides, any kind, okay? I notice then underneath triangle that it goes to acute, right, and obtuse. So if I think about acute, right, and obtuse, what I remember from 4th grade is that those are all types of angles, and I know that an acute angle has to be less than 90 degrees, a right angle is exactly 90 degrees, and an obtuse angle is greater than 90 degrees, okay? So all of those, thinking through that, I know that the total angles in a triangle is 180 degrees, so that's gonna be kind of important. Okay, so my second question is, how can I list my shapes before putting them into a diagram? The why is I must look for and make use of structure. So if you remember there, that math practice 7, we're just looking for a pattern. And tree diagram actually sets up this pattern really nicely for us. So it's already listed, but I want to notice that the equilateral triangle, all of those angles are equal. And if all of those angles are equal and they can only add up to be 180 degrees, then I'm gonna have to think, well, in a triangle, there are 1, 2, 3. Okay, so 3 angles, 180 degrees divided by 3, that would be 60 degrees. So if every single angle has to be 60 degrees in order to be equilateral, I also know that 60 degrees is less than 90 degrees. So if it's less than 90 degrees, it's acute. So what that's saying is that equilateral is actually a subcategory of acute triangles, okay? So thinking through that, it says, which diagram should I use to reflect my list or table? Why I must attend to precision, that math practice 6. Well, the tree diagram is already used, and I have just verified that, hey, an equilateral triangle is a subcategory of acute triangles, and that of course, acute triangles are triangles. So able to use that diagram to really verify that. And as I'm thinking through this, this is kind of how I would answer this question. Because I was able to do all of that thinking up front, I'm going to say, hey, I know that all equilateral triangles are also acute triangles. Equilateral triangles have angles of equal measure, and we just said those equal measures would be 60 degrees. Acute triangles must have angles less than 90 degrees. Since a triangle only has 180 degrees, each angle must be 60 degrees to be equilateral. Since 60 is less than 90, equilateral triangles are also acute, okay? So I know that they just asked for one single statement, but if you're really pushing to understand this, then you're able to really go through and justify every piece so that when I get to guided question number 4, is my answer reasonable because I'm using these appropriate tools strategically? My appropriate tool, of course, is the tree diagram. I'm able to say, hey, yes, I was able to verify my answer using that tree diagram and able to thoroughly explain it so that if anyone were to ask me, I could talk about it, I could draw it out, I could show them, okay? So that's just one example. We're gonna move into another example using these same guided questions. So in this problem, and we're always gonna read the problem first and then we'll go to the guided questions. It says that we are going to create a Venn diagram to show the hierarchy of triangles, quadrilaterals, isosceles triangles, and polygons. So again, going through your guided questions, guided question 1. What attributes do I notice about the shapes? Why I must reason abstractly and quantitatively. Okay, so the shapes here that they have listed are triangles, quadrilaterals, isosceles triangles, and polygons. So I notice, again, triangles are polygons with 3 sides. Quadrilaterals are polygons with 4 sides. An isosceles triangle is a triangle that has 2 sides of equal length. And then a polygon is a closed figure with 3 or more connecting line segments. Okay, so if I'm thinking through that, I know that polygon, that's pretty general. Okay, it says, how can I list my shapes before putting them into the diagram? So before I start ever drawing my Venn diagram, I really want to list them out and make sure that I have a deep understanding so that the Venn diagram is just super easy. It's my visual, okay? It says why I must look for and make use of structure. So what I'm trying to do here with Math Practice 7 is now I'm going to take this and I'm going to create the pattern for you, the visual pattern. So as I'm doing this, I know that polygons is the most general because we said triangles were polygons and an isosceles triangle is a type of triangle, so therefore it's also a polygon. And I know that a quadrilateral is also a polygon. It's polygon with 4 sides, okay? So as I'm thinking about this, I know that triangle and quadrilateral, they're both types of polygons. And then I'm thinking very specifically about that isosceles triangle being a type of triangle. So as I list through that, I'm going to need to think about where do I put triangles and quadrilaterals so that it makes sense, okay? Guided question 3. Which diagram should I use to reflect my list or table? The why is I must attend to precision. So friends, if I'm attending to precision, I'm going to make sure my Venn diagram that it is laid out very clearly as to what is supposed to go where, okay? So I'm going to go ahead and show you our Venn diagram. And because we said we started with polygons, that's what we're going to start with. So we started with polygons as the most general. Inside of it, I had to figure out how I could list triangles and quadrilaterals. They're both polygons, but they don't actually fit inside because a triangle is not a quadrilateral and a quadrilateral is not a triangle. They're just both polygons. So I listed them beside one another, which looks a little funny, but totally acceptable. And then inside of a triangle, I know that very specifically that subcategory isosceles triangle needs to go, okay? So thinking through that, which diagram should I use? I use the Venn diagram because that's what it asked me to create. So I want to be specific. I want to make sure that I'm following those expectations, okay? Number 4 says, is my answer reasonable? Why I must use appropriate tools strategically. So I used this Venn diagram, that was my tool to list out these shapes. And it is reasonable because I was able to show polygons as the most general. I was able to then show that a triangle and quadrilateral, those are both types of polygons. And then I was able to even more specifically show that an isosceles triangle is a type of triangle, which also fits into that general polygon, okay? So we're going to go through at least one more example, and I want you really thinking through these guided questions. In just a few moments, I'm going to actually have you work on your packet using the guided questions. So we have this problem here, and it says, look at the tree diagram below. So we have another tree diagram. We have polygons, triangles, quadrilaterals, pentagons, and then we have trapezoids. All right. So I'm going to go through here. We're going to answer which statement is true. Circle the letter of the correct answer. So before I ever get to those answers, I want to think through the guided questions one more time. Okay, so guided question number 1. What attributes do I notice about the shapes? Why I must reason abstractly and quantitatively. So if I am noticing polygons, I'm looking at this tree diagram. Polygons is the top. So that means it should be the most general, okay? Underneath that, I see triangles and quadrilaterals. We just said triangles and quadrilaterals were types of polygons in that last question, so that works out beautifully. Beside that, I see pentagons. So pentagons I know are polygons with 5 sides. So I agree it is a polygon. I agree that it could not be with triangles or quadrilaterals. That works perfectly. I noticed then that under quadrilaterals is trapezoid. So if I think about a trapezoid, I always think about the circus and the little things that the elephants stand on, okay? So we got those trapezoids, and I see that they have 1, 2, 3, 4 sides. If they have 4 sides, oh yeah, quadrilaterals have 4 sides. Okay, so I've thought through all of those. Now I'm moving to guided question 2. How can I list my shapes before putting them into a diagram? The why is I must look for and make use of structure. Well, here's the nice thing. The tree diagram that they gave us, we now were able to verify and say, hey, this is correct. So we're not going to have to list them out because it's already done for us. Guided question 3. Which diagram should I use to reflect my list or table? Well, again, I'm using that tree diagram. So I'm going to go through and I'm going to see, well, can I now answer this question after we've thought through it? Okay. A says all polygons are triangles, quadrilaterals, and pentagons. I really wish they had said that question differently. And the reason is because that's not totally true. Think about it. Are the only polygons that we have triangles, quadrilaterals, and pentagons? What about in our example of the definition of polygons when we talked about hexagons? Hexagons have 6 sides. They're polygons. So we know that A is not true. Okay? And I want you to now think about B. All quadrilaterals are trapezoids. So what they've done here is they kind of flipped it over and made trapezoid a category and then quadrilateral the subcategory. So I want you to think through that. Is every single quadrilateral you see a trapezoid? What about squares? What about rectangles? A rhombus, all sorts of quadrilaterals out there. So we know B is also not correct, okay? I'm gonna look at C. It says all triangles and quadrilaterals are polygons. Well, here's the cool thing. We have already discussed this even in that last problem. So if I were doing this, I would have put a little star because I still wanna make sure that I've gone through every single answer to make sure I haven't missed something, okay? I'm gonna come back. D, triangles, quadrilaterals, and pentagons all have the same properties. Well, we know that all of them are polygons, but think about the sides in a triangle, a quadrilateral, and a pentagon. Are they all the same? If they're not all the same, then we cannot say that they have the same properties. We could say that they're all polygons, but we cannot say that they have the same properties. So because of that, if you said that your answer was C, give me an air high five. You were correct. So we have this same problem, and what's cool is we don't really have to go through the guided questions because it is the exact same tree diagram. And we're going to look here at this second portion, okay? So we know that the answer for that was C, but it says Dinah chose B as the correct answer. How did she get that answer? And it says B, all quadrilaterals are trapezoids. So how do you think? Take a moment, and if you want to pause this and just think through, why do you think she chose that all quadrilaterals are trapezoids? Okay, well, if I'm thinking through this and I want to answer this, I would have said that, hey, she just switched the subcategories. If B said that all trapezoids were quadrilaterals, she would be correct, okay? But we know that all quadrilaterals cannot be trapezoids because we have squares, we have rhombuses, we have rectangles. So kind of really thinking through that, I went ahead and added that visual in because for guided question 4 is my answer reasonable. I want to use as many tools as I can to justify my thinking. All right, so we're gonna go through one last one and then we're gonna really dig into your packet. It says, what attributes do I notice about the shapes? Okay, so we have this example here. I was just thinking through those guided questions, knowing what I'm getting into, and it says, Chin wrote some names that can be used to classify this shape in order from least specific to most specific. Do you agree with what he did? Explain. Okay, so looking at this, he says that it's a quadrilateral and then a parallelogram and then a square and then a rhombus. So if I'm thinking with that guided question 1 in my head about the attributes of those shapes, I know quadrilateral is a polygon with 4 sides. Parallelogram is a quadrilateral, it has 4 sides. It also has 2 sets of parallel sides. Okay, good with that. A square, so square has 4 sides, obviously. It has 2 sets of parallel sides, but it also has 90-degree angles. And I'm going to hold off on that, but I have some confusion there because if I look at that shape, it's not showing me that there are 90-degree angles. And then I look at a rhombus. So a rhombus, it's going to have 2 sets of parallel sides. All of the sides are going to be the same length. It's going to have 4 sides, so it is a quadrilateral. So I want to think about that. How can I list my shapes before putting them into the diagram? So that's that guided question number 2. If I were to relist these, I would take out square. And the reason I would take out square is because this shape right here doesn't have right angles. There's not the little square inside the angles to show me that it has right angles, and it doesn't look like it has right angles, okay? So if I were to relist these, I would say quadrilateral, parallelogram, rhombus. I agree with those 3. I think he just needs to take out square. Which diagram should I use to reflect my list? He used a sort of flow chart, so I would use the same, I'm going to use the same diagram he did to justify my answer, okay? So as I look at this, I'm going to respectfully disagree with Chin because I know that a rhombus does not have all the attributes of a square. So a rhombus itself doesn't actually have 90-degree angles, so it's not going to come after square in this particular situation. And if Chin removes square, then I would agree with his solution and showing the flow chart that I've actually created. All right. So we're going to keep going, and as we think through some of these next problems, I want you to really dig in and I want you to think about your packet, okay? Here's some more examples. If you need them, you can go back, pause, look at these, think through some of them, but I really want to dig in to your packet. Okay, so this problem is in your packet. If you'll look, go ahead, I would pause right now after reading through the guided questions, try this on your own, and then press play. Come back and see, hey, did I get this right? Okay? All right, so I'm gonna go ahead and go through it again. If you wanna try this on your own, press pause now and press play when you're ready. It says mark an X in the column if the shape always has that property. So here they've given us a chart and we're supposed to put an X if the property exists always. So guided question number 1, what attributes do I notice about the shapes? Well, a parallelogram. I do know that it has 4 sides, so I can put an X there. It has 2 pairs of parallel sides, X there. 4 right angles. A parallelogram does not have 4 right angles, so I'm not going to put an X there. Okay, so now I'm going to go down. What attributes do I notice about a rectangle? It has 4 sides. It has 2 pairs of parallel sides. 4 right angles. Yeah, a rectangle has 4 right angles, so it has every single one. That's pretty specific, okay, because it has a lot of those attributes. And then what attributes do I notice about a quadrilateral? So quadrilateral has 4 sides, 2 pairs of parallel sides. It could, but it doesn't have to. A trapezoid is a quadrilateral and it only has 1 pair. and then 4 right angles. If we continue using the trapezoid as an example, it does not have 4 right angles, okay? So guided question number 2 is what I'm moving to. And I'm going to use that to actually answer this next question, which says use the table in problem 3, so that's that table there, to make a flow chart that shows the relationship between the 3 shapes. Order the shapes from general to specific, going from left to right. So if I'm thinking general, it's going to have the least amount of X's because it has the least things describing it, okay? And the most specific one is going to have the most. So guided question 2, how can I list my shapes before putting them into the diagram? Well, if I just look at X's, I would say a quadrilateral is first, a parallelogram is second because there are 2 X's, and then a rectangle is going to be the most specific subcategory because all of those are X'd, okay? Which diagram should I use to reflect my list or table? That's guided question 3. Well, I'm going to use a flowchart because that's what they give me. So here I'm going to say quadrilateral, parallelogram, and rectangle. If you've gotten all of this right so far, then again, give me an air high five. Good job. Okay. After I look at this, it says, where would you include squares in the flow chart of problem 4? Explain. So I just put here that I would put squares to the right of the rectangle. So I put it on the other side because squares share all of the properties of a quadrilateral, parallelogram, and a rectangle. Squares have the 90-degree angles, but even more specifically, they have congruent sides, meaning all of their sides are the same length. So if you set all of that, then you're able to justify guided question number 4, is my answer reasonable? I really appreciate all the hard work you're doing and for joining us today, and I am so glad to be here with you. I want to leave a couple things for you. First of all, the only way to learn mathematics is to do mathematics. So if you are worried about those shapes, draw it. If you have some shapes at home, get them out. Otherwise, don't stress about it, okay? It's been really fun working on shapes and thinking through that stuff with you. Last but not least, a pun because I had to. Parallel lines have so much in common. It's a shame they'll never meet. Join us again. Have a great summer. See ya.